Welcome, everyone, to our next chapter, chapter 5, which is after chapter 3. And we're going to start talking about structures. And really, we're talking about graphs here, but how they tie into computer science is through structures, and specifically data structures. So you all are going to be taking a data structures course next quarter. But we'll get into some of the mathematical side of it as well, because most data structures are going to boil down to graphs or trees. And we're going to talk about those in this chapter. And specifically, we're going to, of course, talk about the abstract mathematical concept, which you can then use when you implement through coding and other things on your own. So that's pretty exciting. This chapter is going to be a bit of whiplash. Last chapter was very mathy. This chapter is going to be much more computer science focused. So that'll probably be good news to some of you. To start, we've already talked a little bit about some graphs, right? When we were talking about relations, we said we can view relations as graphs, and specifically we talked about digraphs, right? So, let's say, we had, some elements, A, B, and C, and we had some numbers 1, 2, and 3. We said, oh yeah, right, we can make a digraph over here. 1 is related to A, 1 is related to B, maybe 2 is related to itself, right? We did digraphs. Maybe 3 is related to C, and C is related to 3. We've done this before. So we're going to talk about that in more abstract and talk about some of the things that we can do with them. But here's an example of graphs. Now, I probably should have said this earlier, but I do want to say that graphs are not, well, it's true. It's just like functions, right? When we had our chapter about functions, I said this isn't really like the functions in pre-calculus, even though it is. It's just the abstract version of functions. Well, similarly, this chapter we're talking about graphs, but it's not really the graphs of, your pre-calculus, calculus stuff. Although, again, it really is like the abstract version of that as well. Okay? So, just to give you a couple things to think about for things that, we could use graphs for, right, is we could visualize social media as graphs. So let's say, we could create a graph of every Twitter user, currently known as X. Anyway, I'm not going to say that. Every Twitter user, right? We could make a digraph of all the people that those Twitter users follow. Now, this would be a huge graph. You would never write this graph all down, right? And in fact, most graphs are so huge, we never actually visualize them. So that's why this mathematical concept and all these algorithms that we're going to introduce in this chapter are so important, because yes, when you have a picture, that makes it very easy to learn concepts. It makes it very easy to visualize things. But in reality, right, nobody's making a picture of most of these graphs. They're just too big. So that would be a good digraph. If we, thought of Google Maps. The author of our textbook keeps bringing up MapQuest. I don't know anyone under the age of 60 who uses MapQuest, but maybe you do. Power to you, right? We could think of a bunch of vertices, a bunch of nodes as different places you might want to go, right? And then we could connect them. This would probably not be a digraph. This would be an undirected graph, but you could make it a digraph for, how to get there and how long it's going to take and stuff like that. And we could be interested in the shortest path between two things and how can we connect? What things are connected? What things are not connected? All these things that we're going to talk about, and we could visualize with that. And again, this one, I guess we do sort of visualize, but not in the same way. You could think about web pages, right? Which web pages are hyperlinked to others? That could be a bunch of different nodes and connections. That would also be a digraph, right? It wouldn't necessarily be symmetric. Remember, symmetry means that if you go one way, you also have to go the other way. So digraphs are typically not symmetric, but they could be. So that's basically what we're doing here. Okay. That's what this chapter is all about. That's what we're introducing. We're going to talk about graphs. We're going to talk about trees. We're going to talk about algorithms. Specifically, how can we traverse these graphs? How can we go through every node on these graphs? How can we find the shortest path between two things on this graph? We're going to talk about binary trees. We're going to talk about rooted trees and more stuff. It's going to be a very that's not the right word. It's going to be a very full chapter. I'm excited to talk about it. I hope you're excited to be here. In the next video, we're going to start talking about some definitions. We have a lot of terms we need to introduce, but don't worry, we're not going to spend too much time giving really long paragraph definitions. So stay tuned and have a good one.